What's up, Tube? Welcome to Low Guido's Chop Shop, second best gel blaster channel on the tubes. And tonight I have a T238 Brushless 480 motor, and I gotta say, this I've ordered a lot of motors from China, and I've never seen one packaged quite like this before. Let's take a look at this. It's got a nice alloy finish. It's got some specs on the back here. It's got a serial number. Interesting. It's got some specs here. So we got 2,980 kV, but they've also listed that as RPM. So I don't know if that. I imagine they mean 2,900 RPM, not kV. Anyway, there's an adjust button there, and it also comes with a tool. I've never actually seen a motor come with a tool before. It's got a little tool. I wonder if that must be to make adjustments or something. I'm sure I'm going to find out all these things. And it comes with a little bag of terminals as well. So looks like it's got 1, 2, 3, 4, 5. That's an odd amount. 5 terminals. 2 pairs and a spare. So there's enough terminals there for you to do whatever you want with. But I'm interested in this motor, what it's capable of. Now, there's no instruction manual provided, so I'm going to have to learn exactly what all this is about. Now, it is a brushless motor, and I do know a little thing or two about motors, and I know that generally brushless motors run on a 3-phase motor controller, or a ESC, electronic speed controller. Basically, your brushed motors generally run on a DC voltage. They run on just pure normal DC, whatever voltage you put in there, that spins them. Whereas a brushless motor generally runs on a 3-phase AC system, which means there's an electronic circuit somewhere that converts DC into 3-phase AC, and I hazard a guess that it's inside this motor somewhere, because there's only DC inputs, and we only put DC inputs into our blaster motors. So I might have to. Oh, is this the tool for that? Oh, it is the right size. I wonder if that's to take that apart. Well, you know I'm going to have to, right? You know I'm going to have to. Alright, so the little tool screwdriver that they provide is the right size to get these screws out. So, so here we go. I'm taking it apart, see what's in it. There's got to be a controller, right? There's got to be like a little MOSFET controller in here. That's what I'm betting on. If they didn't want me to take it apart, they wouldn't have given me a tool with the exact right size bit on it, would they? That's what I'm going with. Let's take that spring off out of the way. Oh, there we go. There we go. You see this? Little capacitor in the center. And then there's a little circuit board, little controller in there. And okay, so here's your, see, you remember I mentioned there's 3 phases, so there's one there, and a third one there. So 1, 2, 3. So this this little board is your speed controller, essentially. It's got a variable resistor here as well, potentiometer. So this is to adjust something. I guess you might be able to adjust the RPM. As I said, I don't have a manual, so I'm winging it. But yeah, it does look like it's got a small microcontroller in here, so yeah, I imagine that can adjust the speed or the RPM. Now it is a flathead screwdriver, not an Allen head, so I thought that the screwdriver they gave me would be to adjust that, but it's actually not. It's a small flathead to adjust that. So this is literally specifically for taking these screws out, which is interesting. Is there a reason why I would need to take these screws out? It does have some heat sinking compound on the other side of the board there, so I imagine the MOSFETs are probably located on the other side of the board. I'm not going to pull it off because it's soldered to the motor phases, and that would require some degree of removal. Ah, see these 4 or 5 pins here, 5 pins there. That'll be the hall sensors. So they have hall sensors in the unit to determine the position of the rotation of the motor, so that it knows which phase to light up in which order, and that's designed for higher torque applications because you can provide the actual controller knows which phase to light up in which order. Now you can get away without censored arrangements. You can use sensorless speed controllers, but generally speaking, the startup of a sensorless is not very smooth. So as the motor starts up, it doesn't necessarily know which position it's in, so it doesn't know which phase to light up first smoothly. So sometimes it can sort of sit and rock between phases before it actually starts spinning. When you give it the juice, it'll eventually start spinning. But having sensors is a good thing. So that'd be what those ones are. Cool. All right. Well, let's whack it in something. These pins are meaty as well. They're quite solid. Like, to put that into perspective, let me grab a motor. Alright, so this is a fairly generic LDT motor. Let me just zero my caliper. Alright. Yeah, so this is a fairly generic LDT, and you can see that the tabs are 3mm thick. If you can see that. Yep, is that on screen? Yep, excellent. So did I say 3? Because I think I meant 0.3. Is that 0.3? Yeah, sorry, 0.3. Yeah, 0.3mm thick. It's very important where you put the point, the decimal point. These are 0.65. They are twice the thickness of your average motor terminal. Now, maybe that's why they give you so many spade connectors, because your standard ones might not fit over them. You might have to stretch them a bit. But regardless, they've given you 5 of the damn thing, so there's plenty to go around. Easy enough to change. Now it does look like it comes with a fairly hardened steel sort of pinion gear. Pretty nice looking, better than the average one that you see on most motors. I'm still perplexed by this tool. This is an amazing little tool. It's literally a aluminium, you know, it's probably it's turned down on a lathe or something that like to. It's got this. It's a nice little tool, and I the only purpose I see for it is literally for undoing these screws or doing these screws up. Which, I mean, if they give you a tool, kind of implies that they want you to do it, or they endorse taking that. I don't know why you'd need to take that off though in ordinary circumstances. Anyway, let's test this thing out. Now I've got here, let me zoom out. Now I've got here an APS gearbox that I was going to destroy for scientific reasons, and I think this is a good opportunity. So basically I think what I'll do is I'll get a standard-ish motor, like some run-of-the-mill motor, hook it up to this, run it up on the standard spring, then I'll increase the spring and we'll run it up, and we'll run it up on the brushless motor as well, and we'll compare the current draw, and we'll see what motors can pull what springs. I guess that's the best way to do it. I mean, I imagine this has got to have some torque, right? Brushless have generally got good torque. We're going to find out. Alright, does anyone out there recognise this grip? If you do, if you're one of my subscribers, you may recognise this grip, and you might know that when this grip comes out, bad things are about to happen. So I've got a pretty standard run-of-the-mill motor here. I'm just going to whack that one in first, and we'll run it up and we'll see how she goes. Alright, putting the standard motor in. Okay, so what I've got here is I've got a standard motor with the standard APS spring, and we're going to run this for a minute. Then I'm going to up it to a M120. We'll run it for a minute. We'll take notes of the current draw, and we'll also take notes of just how the motor sounds and what the, you know, whether it sounds like it's struggling to do the job or not. Then I'm going to do the same thing with the brushless motor, and we'll compare, you know, current draws and just what the motor generally sounds like, if it sounds like it's struggling to pull the load. As an added benefit, we'll probably destroy this APS gearbox in the process. This is straight out of the box, and I'll be honest, I've already had to jig the shimming a bit because it was terrible. I haven't spent a lot of time getting it perfect, so something's probably going to break. Let's be honest. That'll just be an added bonus. Alright, so you pro on, I pro on. Here we go. Alright. Something has already stopped there. Oh wait, no, that could just be the... Something's already stopped. Already. Alright, let's see what is going on there. Okay, well, I was expecting a failure, but I wasn't expecting a failure this soon, and I wasn't expecting a failure of this type. Nothing actually broke. What happened is the pinion gear actually worked its way up and jammed into the gear, allowing it not to turn anymore. The grub screw had come loose, and that now brings me to my next point. I'm a big dummy. I know why they included this screwdriver now. It's for the grub screw on the pinion gear. Because how often have you stripped the heads on grub screws because you're using cheap, inferior, crappy Allen keys? now they provide a nice good quality screwdriver for it. That's excellent, I like that. But let's get back into this. I think we'll move it up to the 120 now because we got the data. I think we got enough data from the stock spring. Let's ramp it up. Let's go. Send it. Alright, so we've got the M120 in now. We're going to send it. We're going to take note of the current and what it sounds like, and then we'll whack in the brushless. Alright, ear pro on. Here we go. Alright, that sounds tough. We'll observe the current readings. I think we got a max of 27 there. Look like an average of around 16 amps. I'm sorry, my actual ammeter was a little bit overexposed in the footage, so it's hard to read. But I'll fix that up for the next round. And now we'll whack the brushless in. Alright, chucking in the T238 brushless motor for the first time. Connecting the wires up. A little bit exciting, I've never used one before. So we're gonna see how it all goes. Alright. Just gonna tuck these wires a little bit in here. Alright, got the T238 brushless motor in there, and you'll notice I don't have the screw in the bottom here because just the way the motor was set, the adjustment screw on the bottom was all the way backed out anyway, so it doesn't matter. There's no tension on that screw with this motor. Alright, let's send it. Let's send it and also probably destroy this APS gearbox. Alright, keep an eye on the current draw on this. Alright, ear pro on, eye pro on. Ready? Contact. Wow, listen to those RPMs. Oh. Something just died. Alright, I think, just judging by the fact the tappet plate's still moving and all the gears are still turning, but the piston's not pistoning, I believe we might have lost a rack gear in that. But did you hear that sound and see the current draw? Like, the current draw was very similar to the other motor, but did you see the peak? The peak was much less. Only a max of 19 amps. The initial inrush current is a lot less. Another thing that you can't actually see on the camera is the temperature of the grip. It's not hot. It's warm, like mildly warm, but like with the other motor, when you crank it up with this M120, it gets hot, it gets toasty. Alright, got a new piston in, got the brushless motor back in. I'll tell you what's blowing my mind about this brushless motor. Listen to this. Like, I can barely hear anything but the piston slapping. Like, I don't hear any gear noise or anything. No whine from the motor, nothing. Just the slap of the piston. That's blowing my mind. So the brushless motor is definitely more efficient, and I mean, one of the benefits of a brushless motor, let me zoom in here and just let me show you on a brushed motor something that can't happen with brushless. Alright, so in case you're wondering what a brush is, this here, this is the brush. It's a sort of a sacrificial contact that rubs against the armature as it's spinning around there. And I don't know if you can see in there with my camera, but see those scorch marks? Scorch mark there, scorch mark there. Every time it changes from one coil to the next, big scorch mark there, big scorch mark there. It burns away at the copper, and it burns away at the brush as well. This is something that can be avoided with brushless because there's no brushes to burn. The brushless motor is capable of some great torque and it's got some great benefits, but it also comes at a price. If you can afford it, then that's good. Go for it. Definitely advantages to be had, but it might be out of reach of the average player, perhaps. Alright, that's it from me. Thanks for tuning in to this episode of Low Guido's Chop Shop. And if you like what I'm doing, you can support my channel by buying me a coffee. If you want this brushless motor, you can buy this from T238. There will be a link down there as well. And if you want to pick up a patch from me, just send me a message on Facebook, on my Facebook page, Low Guido's Chopters, and we can organise that. Also, if you want to see me finish off this APS gearbox, I'll be doing that in another video as well. Thanks for watching. Peace.